Thanks everyone for coming tonight. So this is the second IDSA HTX design series event that we've done here in the ION. If you're not a part of IDSA or you're not familiar, it's the Industrial Designers Society of America, which is the national professional organization for industrial designers, and we are the Houston chapter. So if you want to get involved, please reach out to me, Mehdi, or Jeff, who are in the audience today, and let us know, because we're really trying to deliver some great speakers, and I'll introduce Marshall in a second. But on the topic of design, entrepreneurship, how industrial designers can be entrepreneurial, get their products manufactured, and generally succeed, in the complicated and shifting world that is product design. So yeah, without further ado, I'll introduce Marshall. Marshall Whitney is the founder and president of Raum Industries. He's had a decade of project management experience before he started his company in 2016. And they actually started manufacturing furniture, and now he's grown it to 30 employees, doing all sorts of work at steel fabrication, product design, and development. It's a fantastic shop that I've had the opportunity to visit, and he also employs a number of industrial designers and graduates of the U of H program, which I'm an alumni of, as well as a lot of faces in the room. So yeah, without further ado, Marshall's presentation is on the topic of design for manufacturing and how you can create your designs to be more manufacturable and producible. So yeah, thanks everyone for coming, and let's get started.
Hi, I am Marshall, and I am well known for not speaking very loud. So if you can't hear me, please let me know. This is from design to manufacturing. I was asked to do this by Neil and probably Larry. This is a topic Larry and I have talked about for years and years and years, since we first met. I'd like to thank you for coming, for having a mechanical engineer here, which I am. I know this is a very industrial design scenario here, but thanks again. I'm going to try to keep this more about the nuts and bolts of this process. A lot of you know me as a dream crusher. I like to cut right to it and get to the meat and the heart of a matter, and instead of just wasting time on a lot of fluff. But some of that fluff has to be here to validate who I am, I guess. Neil gave a good introduction there. We started in 2016, 2017 was our first real ramp up. Now we've done several thousand tons of what we call design products, especially for oil and gas and energy industry. We have something like 13 CNC machines of various flavors, a little over 30 employees. And today we'll just talk about what design for manufacturing is, who needs it, and how to do it. That's the thing I think most people are here for today, is exactly how to do this thing. What is it? So I think design for manufacturing is just a reason to make better products at a lower produced cost. This gets your product to market. And the biggest thing that we see as a design and fab shop is folks coming in, they're like, want this thing made, like, oh, I'm going to sell this for $400. Like, no, it's going to take $400 to make that. And getting that mindset put into place with you as a designer and your customers and everyone is the key, and the what and the why we're here to do this. So if you Google design for manufacturing, which I did to make this presentation, this is what comes up everywhere. These 5 tenets: process, design, material, environment, which is how it survives in the environment, not being environmentally friendly, and compliance and testing. Process is how it's made. Design is what are the methods used to design it and the practices you use. Materials, everybody knows what that is. Choose the best ones to get the job done. An environment in this methodology, which you ask yourself, well, how does one worrying about what the environment is affect my design? Is you don't want it to come back to you because it keeps failing and you have to redesign it and remanufacture it. And then compliance, which is all related to the experience you have in the marketplace. And we'll talk about this some more. Who is this for? This is not for Joni. You may recognize Joni Ives. This is one of the guys, the key principals at Apple. He designed a lot of the original Mac products. Guys like him, like Dyson, Steve Jobs, even those folks design things and they revolutionize manufacturing, right? The odds are most of us in here are never going to do that. We're going to design things that get made by your buddy or a small shop like Raum and get produced at, sub 1,000 units. But this guy also understood this concept because you don't produce 100 million objects and not understand design for manufacturing, right? So I'm not speaking about this in the topic, in the frame of reference that he does, but in how Raum approaches it. So all of these things that we'll talk about is our perspective, and I'll use that term, we, our, and that means Raum. So this process and design for manufacturing, the sexy term I think is get your stakeholders involved, and the stakeholders in this are everybody. The customer, you as a designer, the manufacturer, us, distribution and retail. And why that's important, like I can't tell you how many times I've seen a branded badge made for retail and somebody put their logo in the sombrero opening for the hanging tag. Like you must know and understand those things as a designer, because every designer wants the product to be represented how it is in your head, right? All the way to the end. And unfortunately, that means you very oftentimes got to be the smartest person in the room when you talk about design and manufacturing. So that technique, that methodology, loosely applied, is what I believe is top-down design. And what top-down design is kind of the concept of you've got to know the end product before you start the foundation. And that's hard. And that's really hard to do in CAD. There's a lot of CAD programs that are tailored to this. I think one of them is Fusion. Will commonly say like this is a top-down design methodology. And again, it means that you've got to put the cart before the horse to start all this. And to illustrate that, I think Meryl Streep does it best.
I've seen all this before. This is going to be the driveway, so I draw all the other dresses. We have some right here and then around watchers. I think it can be very interesting.
No, it's just baffling to me. Why is it so impossible to put together a decent run through? People have had hours and hours to prepare. It's just so confusing to me. Where are the advertisements?
We have some pieces from Banana Republic.
No, we need more, don't we? Oh. Like, what do you think?
Yeah, well, you know me, give me a full ballerina skirt and a hint of saloon, I'm on board.
But do you think it's too much like,
For the quad from July, I thought that, but no, not with the right accessories, it should work.
where are the belts for this strap? I just have one thread.
These are the design interns not running around wondering.
So different. Funny.
No, it's,
This is you when I send your drawings back.
Still learning about this stuff and this
Stuff. Oh. Okay, I see. You think this has nothing to do with you? You go to your closet and you select, I don't know, that lumpy blue sweater, for instance, because you're trying to tell the world that you take yourself too seriously to care about what you put on your back, but what you don't know is that that sweater is not just blue, it's not turquoise, it's not lapis, it's actually cerulean. You're also blithely unaware of the fact that in 2002, Oscar de la Renta did a collection of cerulean gowns, and then I think it was Yves Saint Laurent, wasn't it? showed civilian military graphics, I think we need to check. that. And then cerulean quickly showed up in the collections of 8 different designers. And it filtered down through the department stores and then trickled on down into some tragic casual corner where you go to fish it out of some clearance bin. However, that blue represents millions of dollars, countless jobs. And it's sort of powerful how you think you've made a choice that extends you from the fashion industry when in fact you're wearing a sweater that was selected for you by the people in the store. In the pipes.
Meryl understands the market, right? Meryl understands the process, and she is showing that, and that I think is why she's on top. And in her statement about these decisions are made for you, that is true in manufacturing. You don't get to come in and say, I want this made cheap and fast, but this way. It doesn't work that way anymore. This world is established, and there's a kind of a way to think about, like, it's been financialized. Like, everyone understands the rules, but very oftentimes the designers don't. And you're trying to bring your ball and come play in our court. We don't use balls in our games. Like, we're doing something different. And this is what we're trying to talk about today, is understanding that so that your thing can get made. Right. So process. The normal definition is the manufacturing process chosen must be the correct one for the part or the product. This is an IDSA meeting. You're saying, I don't know what you're talking about. Right? You don't know manufacturing processes. That's why you're here. This is crazy talk. This is crazy talk to have this kind of a language on the internet to tell you how to do this. So let's cut through that. I'm going to tell you what the processes available are that we have experience in. I'm going to kind of run through a lot of this fairly quickly so that we can get to questions at the end and give you more time for that. So bear with me if it doesn't make sense right away. Sheet metal, what you've got to know, number one most important thing are your bending rules. Ask your fabricator what the bending rules are. Ask them, how does having a feature close to a bend affect it? If you don't know these things and don't understand it, the best example on the internet is that Send Cut Send. Go to Send Cut Send's website and they will tell you all this stuff. And these rules are fairly standard for everybody, but then go to your specific manufacturer and get the exact rules that they use. Next, and sheet metal is pretty fast and easy and cheap to get done here, especially in Houston and in America. Welding, you need to know the available metal profile. That comes from this book right here. Go to Triple F, get the book. It's free. This is going to tell you how to design, because if you design a metal shape that isn't in this book, good luck. Second most important part is, because it's in the book doesn't mean that they have it or that they can get it. And probably you're not buying enough of it to make them get it. Be aware of that. Millwork. We do a lot of millwork. Millwork refers to generally doing things out of wood. A common process for that is going to be CNC routing. If you talk about manufacturing, it's going to be CNC routed, and that means 2D, some 3D, flat cutting of parts. You've got to know and understand that you can only get certain shapes based upon the bits that they sell, because this is about manufacturing, right? You're like, oh, well, they can carve whatever I want. Yeah. If you want to spend 8 hours of machine time on your part, which you don't, because we charge $175, $200 an hour for that machine. So no, you don't want these things. 3D printing. 3D printing is a touchy subject for manufacturing, but there are a lot of people that make a lot of money 3D printing for a living for other people. But as a designer, it is not as, I designed it in CAD, let me send it to the printer and it's going to work. If you've ever 3D printed, it doesn't happen that way. You've got to know, most importantly, that a lot of the stuff is geometry dependent. And so I bring up the term here, professionalism. a lot of people don't like to buy a 3D printed part because it looks 3D printed. It's getting better and better and better. Machines like you see back here are that next wave of the future to get rid of that stuff. But as a designer, know that if this is the process you're calling out, could face kickback in your marketplace. Vacuum forming. We've done a lot of vacuum forming lately, especially for lighting, lampshades, that kind of thing. It's fast, it's cheap, but you have to know mold design. And the best guy here in town, I forget the name of the company, but he'll tell you how to make your molds and how to get your part to come out right. And that's going to save you a tremendous amount of money, because just like plastics, the mold is where the money's at in this kind of a process. Electronics. I am not the most well-versed person on getting electronics manufactured. Larry is. But what I do know from things I've had made, you can get a circuit board cheap, very cheap, oftentimes free. If you watch the right YouTube ads, they'll give you 5 for free. But you got to know what you're doing. You got to have smart people on your team. And the thing I learned, you got to have test procedures to get these cheap boards to you, tested, and sent out to your customer. And don't forget about that cost to do that. Lasers are ubiquitous. They cut what we say is our thinner materials and steels. Even if you get into these new 60,000 watt lasers, we believe you're really peaking out at 3/4 of an inch max. And that's still a thin material in the world of manufacturing. So be aware of what you're choosing as you're designing a part, right? You can cut plastics on them. You can cut cellulose-based materials, which is wood, paper, cardboard, and all that kind of stuff. The downside of laser cutting is you can get burning. You can kill yourself if it off-gasses the wrong thing, and people may not want to do that. So most often we see is that people design a part that needs a sharp inside corner. And they say, oh, laser cut it. Well, guess what, honey? Sometimes we cannot, because we don't like to die from chlorine gas. So come up with a different design. The next one, machining. Listen, we can talk for 17 years about how to design for machining. I think one of the problems is the CAD systems today push machining and push 5-axis machining and push all this sexy machining, and they think that they make you believe that it's available. It is not. 5-axis machines are tied up building the world's most innovative parts right now for the guys like Joni, Musk, and stuff like that. It's very hard for folks like us to get time on a 5-axis machine and make your part cheaply. So think about the geometries you're putting in there. Think about the radius that you put on a corner or a chamfer and how hard that is to do. And can you buy a bit or a tool or whatever to make that done in one opt, where you're not profiling it and spending that machine time. This is the one, and we'll talk a little bit about it, where you need to talk to your manufacturer as you're designing or before you're designing, see what you're capable of. The second part of process, the secondary level of process, is secondary processes. So you say, well, I've got this part that's going to be machined. Well, when it goes to the fab shop, we're working on a radar device right now, and they're like, hey, make this part. Well, we're looking at how to economize the part, and it's a flat plate. Well, what we've come up with is the cheapest way to get a bunch of discs is you don't buy a plate, you buy a round bar and you saw it into disc. And so your material utilization, I think we were like at 38% higher. And this is a big project, and that amounts to savings of something like $20 million. So it matters, right? So you then have to know about sawing and what are the sawing methods available. And I'll tell you what, if you go to some of these suppliers, and we'll talk about who those are later, and you say, hey, can I come see your saw? You bet you can. They love their saws. Everyone is excited about how big their saws are, right? Go see them. Go learn about what kerf is and how you need to, what grip is and left grip and drops. I mean, we have very expensive software, Raum, that just manages our saws. Right? This stuff is very, very important. Holes. It's all about holes, man. That's what they say. There is a million ways to put holes in a part. You need to know which way you're going to choose and if you have access to put that hole in your part. And the reason why is because you as a designer have to call it out, because you don't want me to call it out, because I'm going to do it the cheapest way, right? Because you probably didn't specify the quality of hole that you want because you don't know any better. So learn about it. Learn about the different processes for making holes. Common one we see, if you're in the structural steel side of things, they'll say no flame cut holes. So you can imagine as you're bolting two things together, flame cut holes have troughs on the bottom. They're always egg-shaped and your bolts may not line up. They're always going to be specified as drilled or punched. If you don't do that, I'm going to flame cut them because it's cheaper for me to do that. Coatings. The possibly largest category here, coatings. I think the antithesis of coatings is corrosion, which is something like a $13 billion industry in America. So knowing what kind of coating you're going to have on your product is huge. This is tied to your environment aspect of this and everything, and cost. I'll tell you, we're still learning about coatings. I learned about a coating called Halar yesterday. Halar is great. It's impervious to everything. Methyl ethyls, all the bad stuff. Halar is a forever chemical. It stays around forever. It's like worse than Teflon. It will kill you. But we've got to have it for an application that we're working on. And the second part of coatings is you need to know, like we said, if it's dangerous and allowed in your market, which ties into compliance. We'll get there. This is why we're here, design. How do we design for manufacturing? This is big and broad, but I'm going to cover the low-hanging fruit. Okay. We use Fusion 360. We use Fusion because it is all-in-one, because it's at a great price point. And all-in-one means it has our CAM in it as well. And CAM is what you use to tell your robots how to move. Right. So because we have the robots, we need it. Because you're a designer and you want your stuff made with my robots, it behooves you to use the software that I'm using. That's the trick. Ask your manufacturer, what formats do you want your files in? Ask them at the beginning. And if they tell you a paper drawing is fine, I'll be honest with you, in this day and age, be wary of their capabilities, because they may not have the CNC equipment that you think they have. Some others on the marketplace, SolidWorks was a big dog in product manufacturing. We find that is decreasing. They're losing their market share. Onshape is kind of coming up. It's expensive. SketchUp, don't come to me with SketchUp drawings. Rhino, the same. Rhino is great for architects. It's Grasshopper is a fantastic tool. It is hard to get your files out of Rhino to a manufacturing process, including drawings. So the low-hanging fruit, revision control. I cannot tell you how much money you will lose by the transfer of drawings back and forth while you tweak your design. Do not do this. You started out as design file.f3d. That's a Fusion extension. It turned into design file customer edits. You then went to I fixed it finally edit. How many professors have seen this kind of stuff? Where did I go wrong in life.f3d? Approved design file, final, don't delete. If you're laughing, you're guilty of this. Don't name your files like this, because we're talking about designing for manufacturing, which means other people are involved, right? We don't know what's in your head. And I'm billing you by the hour for this kind of stuff if I have to figure it out. This is what we do. If you can't see, we use a 3-digit customer code. There is a great matrix available and a lot of discussion to help you develop these kind of things. Product product breakdown system, PBS. It will help you name your parts in a logical manner, both in your file and your file names. We use a 3-digit customer code or project code, and then what we call a colloquial name, general arrangement, plan view, like make it simple, simple, because I don't know what you're doing. I don't know your widget name or the bottom left, just make it like normal industry names. And then a revision number. Drafts start with letters, A, B, C, D. You rev up from A to B every time you make a change. Don't forget to change your date. You will lose legal battles by not paying attention to this. Then, when it's issued for construction, issued for fabrication, you go to numbers. You start at 0. 0 is IFC. You rev up after that, 1, 2, 3, 4. You don't save over anything. You just keep going. Okay. That's why the naming is critical. Here's an example for us, SWS C311. This tells us it's from 2023, the 11th month, the 10th project. General arrangement drawing, underscore A. CHP C308-001, 3.8 inch. This is how you say 3/8 of an inch in file, because you cannot have slashes. 3/8 of an inch, 836 quantity 12, 0. This tells us cut this out of 3/8 plate. Everybody in our shop knows that.
I heard you mention dates are looking for it. Where do we put the dates? Inside the file?
In the drawing. I'll show you. Show you an example. In your title block of the drawing. You don't really want to do it in this because there are tags in the file that we know the date the file is made. But if you have a mix matched revision and date, and you're saying, oh, do this and this, say, well, my date doesn't match your rev, you'll get in a bind. And dates in title block information and Fusion is not that automatic. In fact, it's not automatic at all. So it's on you to keep track of that. If you get into some of the older systems that have been around that cost more money, like Inventor, it will automatically update that stuff and you can use tables. But I imagine if you're in here, you're not paying $7,000 a year for CAD. So, the other one, dimensioning. You must, as a designer, learn about GD&T, geometric dimensioning tolerancing. There are people that go on to get PhDs in this. You will never be a master at it, ever. Fortunately, it's never changed. It's been the same since the 70s and 60s. The best way to learn about this is look at drawings. Look at old drawings. There are thousands and thousands of drawings on the internet. And what GD&T means is how you dimension your drawings, how you call out features, how you do all the things. Talk to your shops about it, talk to the fabricators, and then scan that QR code. That is to the machinery's handbook. It's on the table over here. That book will tell you things. Keep that book by your toilet and don't scroll. Read. Read. Use other resources. Engineer's Black Book, which is also over there. I think 15, 20 bucks on Amazon. Get it. You keep that on your desk. That and this stay on my desk. The last resource, AISC, ASME, ISO, all of these standards, the old versions are available free on the internet. And because nothing has changed, it's going to be good enough, right? The other gotchas that you must learn about in design by talking to folks, because again, you don't have experience, right? Bolt holes, part gaps, tolerances, how things fit together. Get some things made and try it out. Go to the machinist. Ask how they like the features to be identified in paper drawings. Because I'd say right now, it is still maybe 50-50 on whether your part gets made on a CNC machine or it's still made on a manual machine if it's quantity 1. So you still do need paper drawings for low quantities. Last biggest one, don't over dimension. Don't over dimension your drawings. That is a surefire way to get things kicked back, because the world is not perfect. And if you constrain something, people won't make it. Let's see what that is. This is a part that we've made a bunch of. It's a biotech reactor. Probably shouldn't be showing you this, but I know that my machinist likes to reference the top left corner as his WCS. So I dimension everything from the top left corner. He knows where all the holes are from there. And what I mean by don't over dimension, if you look through this, there is no way to, what I don't do is I know what this overall part length is. And I know where this hole is from this edge, but I'm not saying where that hole is from that edge. That is a constraint. And I'll kick that back and I'm going to charge you $85 an hour to redraw this, right? That's the top level GD&T knowledge that you must have. And the whole drawing like that. I think that this is a pretty good drawing, you know, if I'm gonna say so myself. And then you've got to learn the tags like on the left, which the modern CAD softwares will do this for you. But this says in the back, 1/4 inch MPT, that symbol means all the way through from top, typical 2 places. Over dimensioning means you would put that same tag on this hole too. That's crowding your drawing up. Your machinist is not a dummy. You know, you can call it out once and tell him in 2 spots, this would be the same. Symbol or symmetric about the center line. So I'm not adding more dimensions to this. He's not a dummy. I say, hey, do the same hole on the other side of center. Right? Well, how does he know where center is? He knows where the edge is, he knows the length. Right? This keeps your drawings clean. You know, I've got some drawings from the 50s of like dam projects. You can find this on the internet. They'll have thousands of details in one page. And that's back when they used to copy them by hand. I bet some of the older folks in here know about that. Looking at you guys. Be aware of clean drawings, right? Because with 3D modeling, you can kind of get carried away real fast. Because you can click through it all real fast. Hardware and fittings. If it's not in McMaster car book, the big yellow one here, don't put it in your model. Stop trying to invent a screw or a clip or whatever. What else has McMaster car done? The most brilliant move they've ever made. It probably has netted them billions of dollars. They give you the models for free. Drag that in there. The part number goes in your BOM. You can order it from them. Brilliant. Repeat your fasteners. Use a 1/4 20 bolt in all your bolts. That way your manufacturer is ordering one, because 1/4 20 bolts, let's say, come in packs of 100. Well, your thing only needs 2, right? Or 37. But if you change it all up, I've got to buy 10 packs of 100. Keep them the same. Reduce the parts. I'm making fun of Spencer here. Don't make brackets for brackets. Don't stack up components that don't need. Just make one bigger component. Reduce your number of parts. Look at your model, sit with your friends and say, hey, how can we reduce this? Design review has never and should never be a way to make fun of people, right? Everybody gets lost in the weeds at CAD. Review it critically and fix these kind of things. Minimize assembly complications. What does that mean? Folks in the factory or wherever it is, they do have to put this stuff together. Think about how it's going to be put together, do an exploded view of your model and look at how it's going to come in and try to make it easier to be built. Manufacturing operations, the number one thing in this is flips and machining. Minimize your flips. Think about, oh, I need this top edge and bottom edge chamfered. Well, the machinist has to take that part and rehome it, redo all that stuff. I'll guarantee it'll double your cost. Joints and connections. This is hard. This is real hard. Adding joints, making things bolt together, making them modular, making it hinge, making it move is the most expensive thing in manufacturing, I think. You've got to add parts to do that. You have tolerances, you have interference, you have all the problems around a thing. And it's not just easy to make any materials join together that are, especially if they're dissimilar. So try to not do that. Or if you do, use best practice, make them snap, lock, click, whatever. Look through McMaster, see what's available already to join your products. Materials. I like materials. These are the things we normally buy. We buy a lot of steel. The typical thing we're buying is A36. That's called structural steel, low carbon. You can get cast alloys, which are your stainless steels, high alloys, which are starting to talk about Inconels and Monels and Hastelloys. We typically buy from North Shore Steel because we need MTRs, and MTR is a material test report that validates what we bought. And when you are specifying where you want your steel from, or in a lot of these products from, you must, to speed up manufacturing or get a handle on your costs, specify a country of origin. Here in the US and in Houston and oil and gas especially, we're not allowed to buy steel from China. You must say that or they will give it to you. Right? Because a common theory is that a lot of the steel from China comes from Russia, who are our mortal enemies, right? So these implications are huge, even at a small level. We buy a lot of our sheet steel in under 3/16 of an inch thick from Curtis Steel. This Curtis Steel is the other type of guy you need to call and say, hey, what do you have? What can I get? In sheet materials, it matters because it only comes in certain widths and lengths. So if you're designing a part that's outside the bounds of that, you've got to get it custom made. Custom mill roll, which comes on a train car, is hundreds of thousands of dollars for one roll. Aluminum, know your series numbers, 3,000, 5,000, 6,000. Those common 7,000 are the hardenable ones. You'll see forgings that gets into your like aerospace and gun parts often. 6,000s are easily machinable. 5,000s can be bent and welded. So if you have a bent and welded aluminum part, it must be a 5,000 series. Brass, 260 free-forming, think bullets. They punch those bullets out, right? They do a deep draw. 360 is machinable. It's got lead in it. It will kill you if you make a cup. Don't make cups, drinking cups, out of 360 brass. These are different colors, though, as we learned. Morris Metals and Farmers Copper. Farmers Copper just got bought out by a big company. I don't remember who it is, but they're great. They have great, very nice salespeople to help you out. Wood. This would be a get you. I bet you a lot of you here like to design furniture. Plywood's not flat. It's not as thick as they say it is. Nor is lumber. A 2x4 is not 2 inches by 4 inches. Ask how many of my interns learned that the hard way. Solid wood is sold by volume, not by length or width or anything like that. So call your lumber dealers, Clark's Hardwoods, Brazos Forest, call these guys, go walk through the place and learn how to buy it. They will appreciate if you're smarter at buying wood. Okay, the environment. This is tough. The easiest way to learn how to tackle this is pay attention to things as you walk around. Common trick we try to pull on our interns is we say, oh, we can identify that metal. Just lick it. Just lick that metal. And they will. They'll lick it. And why that's important is you need to know as a designer, like these chair legs, I'll tell you right now, these chair legs are made out of steel. But if you go and design them as aluminum and tell me to make them out of aluminum, I will. And then we're going to do another iteration. I'm going to get paid again. So just know what things are made out of. A great tip, I don't have it with me. I carry a little tiny knife in my pocket that has a magnet on it. You can ask any of my guys that are here. I walk around and just touch things with that magnet. Is that steel or is that aluminum? I want to know. Right? So test as you go. Order the samples. Any one of the big vendors will give you samples of anything. Test them, drop them, smash them, expose them to chemicals. Pay attention to how the finishes do. The biggest got you in this category is going to be your coatings. How do the coatings perform in the environment? Right. How do coatings get damaged during manufacturing? We have this issue right now in our shop. We sent something to paint because the customer is in a rush for it. And we're like, hey, go on this design. We need a test fit. And like, no, don't worry. We said it's gonna get scratched. And they said, we're cool with that. Get that in writing, folks, if you have to go that route, but know how these things are gonna survive. And then cleaning. Some people do want to clean things. Some chemicals are harsh, right? Especially as you get into organic materials. Some cleaners are going to damage them. Compliance. This is tough. This is tough if you're new, because you don't know what you don't know, right? Ask the customer what the compliance requirements are. Ask them. We build for aerospace, medical devices, extreme oil and gas. A lot of our products now, the reagents are known carcinogens where we can't even receive it in because it will kill us. So you have to say, what is the governing body here so we know how to be safe? They're the ones that know. You will never know all the requirements. Go to the trade shows. You've got to go because there'll be so many people that are giving you so much information with so many of these lectures, and a lot of times free booze and all that, and you will learn a lot. Don't forget, outside of regulations, regulatory governing bodies, there are internal standards and specifications. If you've ever done work for a Ramco, 2 books, 900 pages. Internal specifications. Make sure you don't ignore those in your design, right? It'll get you. So that's it. Any questions? Think we got time for questions? If anybody has any.
You've got to mention plastics on your field, but
Oh, you can get plastics at ANC. ANC is a big shop. They sell sheet goods. They have sample rings. You can go in there and get them. And they also do manufacturing. They will cut, bend, do whatever for your thing. And it's pretty cheap. So y'all probably read it. Plastic pricing is typically linear. A 1-inch thick piece is 8 times more expensive than an 1/8-inch piece. Typically. I don't get into plastic pellets like for extrusion and injection molding. There's a whole other world that I wouldn't even know where to buy it. So I'm not the guy.
aluminum extrusions, you're talking about sheet metal like rolls, but each extrusion is like, mold. So how do you kind of find the thing like?
So there's probably a handful of folks that will make you custom extrusions. One, I think the closest one to us is in Fort Worth, and it's done by the like foot pound. You've got to order either so many feet of extruded product or so many pounds of it. Typically, what I think your minimum spend is going to be like $5,000 or $6,000 to get things extruded in aluminum for your average die size. So like you want some gun shrouds or.
And is that kind of rough compared to overseas prices? It's gonna be a lot more.
I have never seen it work out to where you'd want to get it done overseas, but the batch size I'm familiar with is in that $5,000 to $10,000 range. Like one container load I've seen, and that's all been domestic.
I think checklist is one thing. What about talk about straightness and this is raw stock and it's all perfect and absolutely flat, even the steel and everything else being right.
Right. Every material is perfect when you get it. It's not true. There are acceptance criteria in every industry. I mentioned AISC here. They're the ones that govern like steel. Steel is going to come at you twisted, rolled, bent, all within acceptable allowances. And what everybody does in the raw material sector is there's always minimum thickness allowances. And these guys will sell you the minimum, right? It's all sold by weight. And they're trying to get away with that. And as you design, you're in steel or sheet goods and you're trying to do like tab and slot, you've got to know how thick that material actually is. And what's another like really, woods are always all over the place, twisted, curved, bent, broken. Steel's pretty bad. Steel's getting worse. Quality's getting worse. And in fact, our domestic steel made in the USA that we've received this year, we've rejected all of it. It's been terrible, terrible quality. What else is real bad? Anybody have any thoughts? Yeah.
Sorry if I missed it, but how do you get all your materials to be assembled together? So let's say I get this material from this company and maybe my with another company. How do I get them to communicate to assembly?
So the first step is going to be in your CAD, in your design software. And the trick is getting the rules right that we talked about, like the sheet metal bending rules, and then the whatever rule for whatever material, because like we work multi-material a lot, especially in science. And if you haven't, let's say, don't have this part bent correctly or welded correctly, and you've already designed this 3D printed letter mold for your concrete form that goes inside of all this is a real world example. Nothing's going to work. So understanding that, and then understanding like how the machine is going to produce the part is critical. And the hardest part, right? It goes back to start modeling it, send your model to somebody. And that's where the most common file I think these days that we see going around is step files, because step files are starting to have metadata in them where you can have material properties and the part name and all that stuff. So try that. I got you first.
What CAD software do you guys use internally and why? I heard something earlier.
We use Fusion 360. It's an Autodesk product. We use it because actually when I left college, I'm a mechanical engineer. I couldn't CAD at all. None. And I taught myself. And back then Fusion was free. And I started with it and it grew and grew and grew. And I'm kind of like too deep into it. And I'm the boss, right? So I get to pick. But it's a good price point, and now it's $700 for like 3 years. Yeah, it's pretty affordable to make stuff. And then it has like team modules and a lot of Fusion, which to be fair, now all the CAD systems doing this is a pay as you play feature. So like you get Fusion Core and you need a manufacturing module, or you can add a nesting module, or you can add all these accessories as add-ons, which is nice as a designer. Like you don't need the manufacturing model or module.
Well, and it will version the files on that, which you may not use.
It does version the files up, but it is an unconventional name, and it doesn't sync them very well as you offload them to like your server, which we have our own server where we pull our files down from Fusion, because Fusion's a cloud-based thing. We pull our own files down, but a lot of that's because we're like regulated to do that stuff to protect our own files. And Fusion doesn't play well with that because Fusion wants you to work in the cloud. So the collaborative feature of it is great. We share with a lot of our customers back and forth, and they have this, we don't show it in our drawings, but we QR code all of our drawings, all of our models. So the guys in the shop can scan it on their phone and they get access to the 3D model. And then we share that with our customers, and it's real easy to do that. And maybe other ones do that, but I'm not aware of it. Neil, and then
I had a question on the subject of assembly. We had some really great tips for drawings and GDT. How does that play into making a assembly guide for something for a larger project that might require multiple stages of assembly?
Assembly guides are big. So where they usually get made is in your after your as-built. So an as-built drawing is you've made the thing, during the course of manufacturing, we've slightly tweaked it because you didn't design it very well or makeable. And then you've got to go back and redesign it to update your drawing, right? Then you're gonna make your assembly. Now, I feel like I'm a Fusion salesperson, but Fusion has a good feature where you can do these animations and explode your model and record videos and screenshot and zoom in. That's the best assembly manual you can make. It's also the best sales tactic you can ever have as a designer. If you show your customer that 3D model exploding, sold, they'll buy it. I've never not had them buy it. But to make that manual, man, I think it's critical to move your manuals to a more digital model. You don't see too many folks out with a paper manual anymore, and using those animation features and making more of a video or presentation like this might be the way to go. That answers the question. Thank you. Yeah.
On that same line, say you're, they parts of the bill, having part manufacturing by 2 years, companies. And so that the parts together, are you outsourcing that to the third party or okay, one of the party that you go about?
You can. So that world is changing to where maybe, man, I don't know. So typically like a machine shop where they just want to make the thing and send it to you. And the other guy makes the thing and sends it to you. And then you've got to find an assembly company, which there are. There are people that just assemble and package. If you're to Google it, you probably search for packagers. And they'll put it in the plastic thing, they'll do all the stuff. But there is a trend to be more like what we do, and we are the super, and we oversee all that, whether we do it in-house or not, and we will assemble it. You can find those folks. But sometimes, man, and at low volume, it's hard to do that. It's hard to find anybody who want to help you at you want 10 of something or one. Your best bet is to make sure you include that in your RFQ, your quote to that manufacturer, like, hey, for an additional amount of money, will you assemble this? And check with like I'd say typically it's going to be your welding shops that will do that. They always seem to be like multi-skilled, whereas machinists, they won't weld, they won't bolt things together, but like welding shops, they kind of jack of all trades. If that's the product, yeah. In electronics, it would be
There are a few shops.
Macrofab.
Well, and others that actually do it better. But yeah, there are shops around that do like now now the electronics field is electronics plus a lot of bombs, things like that. So there are other companies that do that.
You're in this area?
Yep.
Start position one. Yeah.
Start specific.
Yeah.
Earlier you mentioned how like putting proper and accurate dates on things can make all the difference should anything come to a legal battle. I was curious, is that kind of intention something that happens often? And are there other ways to like legally protect yourself as a designer or manufacturer that we should be aware of?
She asked about the dates and basically getting sued and how to protect yourself and does it happen often? Every day. Happens every day at our shop. People try to come after us. Everybody's mad when they're getting things built, especially in the small size of things, because it's very personal at a startup size. This thing you built, it's your baby. And I'll be honest, I don't feel that way anymore. I've made thousands of things. I don't even remember. So like I have no emotion to these products anymore. But most people don't, right? And they want to come after you if it's not like what they had in their head. And so the best way to do it is define the scope in writing. Define the exact materials, the exact process, the things you want to do. And then date it, date your drawings, and then tie everything together. Tie the contract to the drawing, to the whatever, to the material specifications, tie it all together and make these like packages that go in. And the way people come after you is most notably is they'll say, well, that's not what I wanted. And you'll say, well, that's what you paid for. And as fabricators, the burden's always on us to prove is what you wanted, what you paid for. And we're getting pretty good at it. I mean, we've never lost these days. And you know, we'll help you with that. We'll help you determine what it is you want. And the best way to protect yourself is those groups that specify things. Go to AISC, go to those things and get those regulations that hold the manufacturer liable. So an easy one is coatings. You say, I want this wet film coated, which is painted. If it's metal, steel, you know, it needs to be sandblasted first because it comes rusty and with the oxide coating. You say, I want that blasted to an SSPC SP10. And that says that thing must be white and clean before you paint it. Send me proof. Then when you paint it, run your mil test gauge over it and give me a 4.5 mil wet film thickness. Protect yourself. Right? And nobody's doing that at the design level. Nobody. I don't ever get any designer telling me stuff like that. They're trusting us to do the right thing. Sorry? Yeah, I don't know if I have one, but I can get you our information.
Any more questions?
Anyone else?
Brass
Yep.
extruded. Can I get that done?
I don't think so. How much money you got?
That's what I'm asking.
Yeah. I've seen it, I think.
It's just, there's a particular thing I want to machine that's 5,000. Extruded to that, it's supposed to be a lot cheaper. So I didn't know this.
Yeah.
Okay.
Brass is fickle and brass is high. Brass is going up.
Very expensive. I just ordered a shoe.
Yeah.
Check the machinery table.
It'll say.
Machiner's handbook. He said, check the machinery handbook. Commodity pricing, we just read an article Tuesday. It's up 25% since October. It's expected to go higher. So if you want to get something made, you better lock that in because all of our vendors are saying you don't have it, the contract by Christmas. Nobody's going to honor it. That's another thing, just kind of your point and everyone's point of getting things made. You know, it used to be 2-3 years ago, people would honor pricing for ever. Now it's one day. One day. So you guys are product designers and you're trying to put a budget together, start your company and your cost of goods sold and all this stuff. You better move. Or if you're not going to, pay attention to the markets and read these publications and journals that talk about future trends in pricing. So steel's up 25% and they pin all that on the end of the United Auto Workers strike, where now there's a more demand in steel, domestic steel in the US. So all these global events affect us little people a lot. Any other questions?
There are no more questions. Let's give Mark another round of applause.
Thank you so much for the thorough presentation, sharing a ton of valuable knowledge. And thank you everyone for attending.